Assalamualaikum and hi everyone. My name is Nur Farhana binti Tahir. You can call me Miss Farhana and I am from SMK Seri Gombak. Before we start, please prepare your Science Form 2 textbook and stationery. Today, we are going to learn about acid and alkali. We are going to cover two learning objectives today. The first one is about properties of acid and alkali, and the second learning objective is on neutralization. By the end of today's lesson, you should be able to first, define operationally acid and alkali. Second, explain the neutralization reaction.
The word acid comes from the Latin word for sour. There are a lot of different household cleaners containing acids. The most commonly used acidic household cleaner is bleach. Reducing bleach uses acids to turn the stain into a water-soluble substance that can easily be cleaned. Toilet cleaners, tile cleaners, and window cleaners also contain acids. Vinegar is also often used in cleaners as its acids can cut through grease and grime. Acidic liquids have low pH levels. Many fruit juices qualify as acidic liquids. Some of the acidic fruit juices are orange juice, lemon juice, grapefruit juice, tomato juice, and red currant juice. These fruit juices are often used in marinades for meats, particularly tougher cuts of meats, because their acidic nature helps to break down and tenderize the meat. Be careful when marinating meat with acidic fruit juices. However, because the acid can actually begin to cook the meat. This is especially true for meats like shrimp and fish. So, don't leave the acidic juice on for long. Most fruits have a low to medium acid level, though bananas and potatoes are nearer to neutral. Due to their high levels of sugar, nearly all fruits are acidic. At 2.3, lemons are some of the most acidic fruits on the scale, as are limes at 4.0. As a primary enzyme in saliva, amylase starts to break down starches in the food you eat. To experience amylase in action, chew on a cracker for a minute and you will find that it starts to taste sweet. Amylase functions in a neutral to slightly basic environment, which is definitely not to be found in the acid bath that is your stomach. Most plants cannot grow well in soil that is naturally acidic, so farmers add fertilizers that are heavy in bases, such as limestone, to neutralize the acidity of the soil.
In primary school, you were introduced to acid and alkali. Acid is a substance that tastes sour and changes the color of blue litmus paper to red, while alkali is a substance that has a bitter taste and feels soapy when it is touched. It changes the red litmus paper to blue. Now, please take a look at the picture. Can you name one example of acid and alkali that is shown in the picture? Well done, pupils! Examples of acid are lemon and fizzy drinks, while examples of alkali are soap, toothpaste, shampoo, coffee, magnesia milk, and baking powder. Now, let us carry out a few activities to study the properties of acid and alkali.
A strong acid is one that readily gives up its protons, and does so even when the ambient pH is low, which means there are already a lot of protons floating around. Weak acids do not give up their protons so easily, becoming dissociated to a meaningful extent only when pH is closer to neutral. Strong bases, similarly, give up hydroxide ions readily even in high pH solutions. Acids are classified as being either strong or weak. A strong acid detaches or separates in a water solution, and a weak acid does not. Acids also conduct electricity and react with bases to form water and salt. Because of this, they are used in batteries to generate electricity. An acid that strongly conducts electricity is a strong acid, and an acid that weakly conducts electricity is a weak acid. One of the most devastating side effects of pollution is increased acidity in rain and groundwater. Rain and groundwater tend to be naturally slightly acidic, usually no lower than 6 on the pH scale. Propionic acid is an organic acid that occurs naturally as a result of the kind of bacterial action found on skin or in the gastrointestinal tract.
In primary school, you were introduced to the properties of acid and alkali in terms of taste, touch, and the color change of litmus paper. Now, we want to discover more properties of acid and alkali in terms of pH value, corrosiveness, and reaction with metals, followed by the aspect of taste and the effect on litmus paper. pH stands for parameter of concentration of hydrogen ion in a water-based solution. The more hydrogen ions there are in the solution, the more acidic the solution is. The pH paper turns to red-orange if the solution is acidic, while it turns to blue-purple if the solution is alkaline. If the solution is neutral, the pH paper turns green. In this picture, you can see a variety of substances which are either acidic, alkaline, or neutral. The range of acidic starts from 0 to 6, whereas alkaline substances vary from 8 to 14, while neutral substances are indicated as pH 7. For this first activity, you need a few strips of pH paper, some vinegar, and shampoo. Now, you have samples of things that are easy to look for in your kitchen. Pour some vinegar into an empty glass. Carefully dip the pH paper into the vinegar. Observe the color change of the pH paper and compare it to the pH color chart. Repeat the same step by using the shampoo.
Litmus paper, or red and blue test strips, will tell you whether a solution is an acid or a base, but it won't give you information about the strength of the solution. Universal or Alkacid indicator paper has a different color to match every number on the pH scale. Neutral solutions turn the paper green. The paper is imbued with dye derived from lichens that change color in response to the presence of an acid or base. Neutral or alkaline fruits include blueberries, avocados, currants, plums, and prunes. Potatoes and bananas are usually classified as neutral. Litmus paper is inexpensive, portable, and can test acidity and alkalinity using only a small volume of solution. However, it cannot provide the actual pH for a substance, other than indicating if the pH is roughly less than 5 or greater than 8. Litmus paper is not useful for testing substances with a pH that is closer to neutral. This pH paper changes color in different pH solutions because of the chemical flavin, which is a pigment present in red cabbage. This molecule, which is an anthocyanin, is soluble in water and changes color in the presence of various types of solutions. In the presence of an acidic solution, it turns red. In the presence of a basic solution, it turns greenish. In the presence of a neutral solution, it turns purple, as indicated by Administrator L. Bry at MedSci Research. In the presence of a strong acidic solution, the pH paper will turn red, and if a strong alkaline or basic solution is applied, it will turn violet. Neutral solutions turn green. The pH scale typically ranges from 1 to 14. The pH or power of hydrogen is a value generally but not mathematically constrained to the numerical range of 0 to 14.0. Solutions that are acidic have a low pH. Neutral solutions, such as pure water, have a pH of 7, and basic solutions have higher pH values. Water with a high pH tends to taste bitter. Water with highly deviant pH values, be it acidic or basic, also tends to leave chemical deposits inside pipes, leading to potential obstruction and degradation. The pH of most shampoos is weakly acidic. A high pH substance opens the hair cuticle, and a low pH substance will help smooth and close the cuticle. It would be good to try an entire lineup of products from one brand, as normally they have started with shampoo being slightly more alkaline and moved down to more acidic conditioner. The leave-in conditioner should reset the pH to normal hair pH. Conditioner has a lower pH, usually around 3.5, to return the hair to its normal range. Shampoo should range between 4 and 8, depending on the job it needs to do. Anti-dandruff shampoo is usually over 5.5, while children's shampoo is usually around 7 to prevent tearing.
Observe and record the color change for vinegar and shampoo. Next, let us investigate the corrosiveness of acid and alkali. For this activity, you need supervision from adults such as your teacher or parent. You also may need to take extra precaution by wearing safety glasses or a mask. In this activity, you need concentrated hydrochloric acid and sodium hydroxide solution. You need to pay attention to the hazardous warning symbols on its packaging before you use it. Look at the diagram. You can see that only concentrated acid and alkali are corrosive. Both acid and alkali are corrosive in higher concentration. Now, let's discuss the reaction of acid and alkali with metal. In this picture, you can see bubbles of gases rising when the magnesium strip is dipped into dilute acid. The reaction between acid and metal gives out hydrogen gas. Only acid reacts with metal and produces hydrogen gas. Alkali does not react with metal. No bubble of gas rises when dilute alkali is mixed with metal. Next, pupils. Let us study the properties of acid and alkali on litmus paper. For this experiment, you need blue litmus paper and red litmus paper. Remember, you still have vinegar from the previous activity? Dip both the blue and red litmus paper into the vinegar. Observe the change in the color. What can you see? Yes, blue litmus paper turns to red while red litmus paper does not change. Next, repeat the same steps with the shampoo. You may want to change to some other things such as Dettol too. Have you ever wondered if Dettol is acid or alkali? Yes, me too. Now, we can test it by using litmus paper. Dip both litmus paper into the Dettol. Observe the color change. What can you see? Yes, red litmus paper turns to blue while blue litmus paper does not change. Now, for the last one, pupils. The taste of acid and alkali. For acid, the taste is sour, and some acids have a strong taste such as lemon. For alkali, the taste is bitter such as bitter gourd. Now, pupils, you have learned the properties of acid and alkali through some simple activities and pictures. Now, let us list down the properties of acid and alkali based on the observation from the activities. This table of observation shows the properties observed for acid and alkali respectively. Pupils, do you still remember how to make the operational definition? You may use the table of observation to create the operational definition of acid. The operational definition of acid is that it tastes sour, it has a pH range from 0 to 6, it changes the blue litmus paper to red, it is corrosive in high concentration, and it reacts with metal to give out hydrogen gas. Now, pupils, please give a try to make the operational definition of alkali. Yes, well done. Alkali is bitter and feels soapy. It has a pH range from 8 to 14. It changes the red litmus paper to blue. It is corrosive in high concentration, and it does not react with metal. Now, what happens when we mix acid with alkali? Have you ever wondered what would happen if we mix these two different substances? Yes, when we mix acid and alkali, salt and water are produced. The salt is in the form of aqueous solution and not in the form of solid. Here is the word equation that explains the reaction of acid and alkali which produces salt and water. This is called neutralization. The example of neutralization is also shown here. Hydrochloric acid mixed with sodium hydroxide produces sodium chloride and water. Pupils, can you tell me how neutralization can be understood? Neutralization can be understood through a method called titration. Titration is a process where a volume of a solution of known concentration is added to a volume of another solution in order to determine its concentration. Pupils, Please look at the steps of titration between hydrochloric acid and sodium hydroxide solution. Firstly, fill 30 ml of hydrochloric acid in a burette using a filter funnel. Thirdly, add 3 drops of phenolphthalein into the conical flask. Next, add the hydrochloric acid from the burette drop by drop into the conical flask while shaking the flask gently. Finally, stop adding the acid when the sodium hydroxide solution changes the color from pink to colorless. This shows that the neutralization is complete. Now, boys and girls, let us discuss the application of neutralization in daily life. The first picture illustrates that soil can become too acidic or too alkaline from excessive use of chemicals and fertilizers. Most plants cannot tolerate this condition, so we need to neutralize the soil by adding some quicklime and slaked-lime to the soil to neutralize the soil. The other picture shows you a tube of toothpaste. Why do we need to brush our teeth, especially before going to bed and after waking up? Well done! We need to brush our teeth to get rid and kill bacteria that resides in our mouth, as the bacteria prefers a neutral to slightly acidic condition, which is exactly the condition of unbrushed mouth. Here are some exercises to see whether you understand about neutralization. Match column A, acid, to column B, alkali, to explain the neutralization process. Well, boys and girls, looks like we have come to the end of our lesson. You are now able to first, define operationally acid and alkali. Second, explain the neutralization reaction. I hope you enjoyed today's lesson. Goodbye and thank you.